now we will gonna talk about four-stroke diesel engine and how does it work. So before we proceed, let us know first the components of four-stroke diesel engine. So we have here a piston that connects to a connecting rod, and the connecting rod connects to a crankshaft and a weird up and down piece of metal. So the piston itself travels linearly up and down within the combustion space, and that is the cylinder on the edge. Here, that is one side of the combustion space. Every time the piston travels down, we call that a stroke, and every time the piston goes up, we call that a stroke. And stay tuned because there are many more knowledge to come.
A fuel injector is a device for atomizing and injecting fuel into an internal combustion engine. The injector atomizes the fuel and forces it directly into the combustion chamber at the precise point in the combustion cycle. There are three elements for fire to ignite. You need fuel, heat, and oxygen. If you lack one of those three, it would be impossible for you to have a fire.
For combustion, there are three requirements, that is heat, oxygen, and fuel. The bottom dead center is the lowest point of transit within the cylinder. Stroke 1. The suction is moving down the cylinder, indicating that we are obtaining oxygen, the first component of the fire triangle. The location that is farthest from the crankshaft is responsible for pushing up the piston is referred to as the top dead center. Stroke 2. Compression. The inlet valve closes as the piston rises, compressing the air inside as they do so. The huge increase in pressure and temperature occur simultaneously as we pump atomized diesel fuel. The temperature will increase the point where the fuel will ignite when we compress the air even further.
The piston is forced downwards because of the explosion. There is a huge increase in pressure and temperature which forces the piston down, and as it travels down, it is going to complete one full stroke, which is referred to as the power stroke. This third stroke allows the energy extracted from the combustion and turns it into a mechanical energy. The fuel contains chemical energy, and as the combustion happens, the chemical energy turns into heat and pressure, which drives the piston downwards, and by this the energy is turned into a mechanical motion. After all the fuel is burnt, what remains is a space filled with exhaust gas which needs to be removed so new fuel could be burned. After the power stroke is complete, the piston travels back up from the dead center to the top dead center. As it moves up, the exhaust gas valves open and the exhaust gas comes out of the manifold, completing the fourth stroke, which is the exhaust stroke.
So we've done already with the fourth stroke of the combustion cycle, which is exhaust. So here are the combustion cycle. First is suction, compression, ignition or power, and exhaust. Alright, for us to easily remember this combustion cycle, just remember this forward: suck for suction, squeeze for compression, bang for ignition and power, and blow for exhaust. Okay, as you can see, this is already the process of the fuel injection. So over 50% of the modern four-stroke petrol engines used already the direct injection or the fuel injection. Right, diesel engine are also known as compression ignition engine, which means we compress the air in order to ignite the fuel. Next is the petrol engines, also known as spark ignition, which means to compress the gasoline fumes to air mixture. Use the spark plugs to tone the ignition correctly. Alright, so just remember that a diesel engine is the compression engine and the petrol engine is the spark ignition. It because it uses the spark plug.
Four-stroke engine uses a lot of components, and these components have to open and close at the correct time in order for the engine to function properly. One of the important components of the engine is camshaft. It is located down the side of the engine or on the top of the engine. It is the one in control when we inject fuel into the combustion chamber, allowing air into the combustion space when the intake valve opens, and allows the exhaust gas to exit the combustion space when the exhaust valve opens. So basically, it controls all the timing of the components. The camshaft itself will be driven directly from the crankshaft using chains or gears. As the crankshaft rotates, the camshaft also rotates, and the timing of the camshaft is directly linked to the crankshaft.
Let us now proceed to the next stroke, which is the exhaust stroke. So when the crankshaft rotates, the camshaft also pushes up the push rod. When the push rod is pushed up, the rocker arm will also be pushed down, which then opens the exhaust valves. And as the crankshaft continues to rotate, the camshaft rotates and closes the exhaust valves again, which means during this time, the rocker arm and spring connected to the valves have already changed as well. So basically, we are using the mechanical energy from the power stroke, which travel to the crankshaft and then to the camshaft that pushes up the push rod and push the rocker arm downward, opening the exhaust valves and using the spring's tensile strength together with the rotation of the crankshaft to return the valves to their closed position. This shows that every part is connected and depends on each other in doing that quick task.
Now you see that it's slightly open. When the piston comes up to compress the air, some of that air will escape, and that means that we're not gonna get what they call a Pmax or a pressure max within the combustion space, and all of that leads to wasted energy. So it's very important that all the valves are pressed up tightly against the top of the combustion space. Now, the camshaft here is also responsible for the timing of the fuel injection and when the fuel injectors open and close. Now, here we have two push rods. One is for the two air inlet valves and one is for the two exhaust gas valves, but there are no push rods for the fuel injector. The reason is that this particular type of fuel injector is not open and closed mechanically. This is actually a fuel injector from a common rail diesel engine, and what that means is that we have an electrical valve. Here's the electrical connection on the top, and this is actually what they refer to as a solenoid valve or an electromagnetic valve. So, when we supply electrical current to the top of the fuel injector, it is going to open, and when we remove the electrical current, the fuel injector closes. So that is a common rail fuel injector.
An adaptive change gearing towards efficiency in diesel engine on board is known as the common rail fuel injection. The common rail fuel injection allows a better control when or not injecting fuel in the combustion space. Let us all remember that 4-stroke engines requires a lot of components than 2-stroke engines, but 2-stroke engines has lower efficiency compared to 4-stroke engines. On board, especially large merchant ships, using 2-stroke diesel engine is more preferable as ships have more space to build additional components. Lastly, 4-stroke engines are only applicable to small, medium applications of machines, while 2-stroke engines are only applied to very small and very large applications.